start with a short video.
조선민주주의인민공화국 핵무기연구소 성명 대륙간 탄도로켓 장착용 수소탄 시험에서 완전 성공. 대륙간 탄도로켓 장착용 수소탄 시험이 성과적으로 진행된 것과 관련하여 조선노동당 중앙위원회는 북부 핵시험장에 우리 핵과학자 기술자들에게 뜨거운 축하를 보내어 왔다.
Let's give a round of applause for the lady in pink. Hello everyone, thank you for attending our talk. As you can see, our talk's title is SiliVaccine, North Korea's Weapon of Mass Detection. So you have something here called SiliVaccine, we have North Korea. We'll soon come to understand how it all comes together. But before we do so, let me shortly introduce ourselves. And that's us. That's actually not Seth Rogen, that's me. My name is Mark, and I'm here today with my friend and colleague, Michael.
Hi.
And we are both researchers at Checkpoint's malware research team. And without further ado, let me introduce you to the subject matter. So, I'll start by introducing you to the story of our research. And how did it really begin? So the whole thing began at one evening. I was going through Twitter and looking for something to read when I stumbled upon the following Bloomberg article called Inside North Korea's Hacker Army. And it turns out to be quite an interesting piece about a North Korean defector who worked for a government agency and ended up doing some hacking. And throughout this publication, I found some sort of notion portrayed by the author of North Korea's, so to speak, offensive cyber operations. And in particular, in one paragraph, the author mentions North Korea's official response to allegations made against it by the West regarding hacking. And I quote, "Formally, North Korea denies engaging in hacking and describes accusations to that effect as enemy propaganda. It says its overseas computer efforts are directed at promoting its antivirus software in the global market. The country has for more than a decade been working on such programs, including one called SiliVaccine." Well, what is SiliVaccine? Well, as you may understand from the previous paragraph, SiliVaccine is an antivirus which is developed in North Korea for the North Korean citizens. So basically that's a North Korean antivirus, or how we like to call it, the Kim Jong-un T-virus. And obviously this is not a product you can find on the internet. It's not something you can download. It's only existent within North Korea. And the version that we are going to talk about is version, it was developed, as far as we can tell, since around 2003. And the version we are going to focus on is version 4.0, which was released around 2013. I should mention that we are also in possession of another version from 2005, which is actually one of the first versions of SiliVaccine, and just have that in mind. So, I don't know if you guys know, but North Korean citizens, for the most part, don't have access to the internet. Instead, they have access to what's called an intranet, which is sort of this glorified local area network controlled by the government. And if that's the case, why would North Korea need an antivirus? Well, there are a few interesting explanations for that. One is actually to protect against smuggled media. And in particular, there is, it seems to be a phenomenon of USBs that get smuggled inside the country and then get sold in the North Korea's black market. And if you don't believe me, that's fine, because still it's North Korea we're talking about. But to corroborate this, you can check the following website called Flash Drives for Freedom, which is actually, and I shit you not, a crowdsource funding thing for USBs that get smuggled inside North Korea. So you can today donate your USB, which will get magically inserted into a North Korean computer. And if you're afraid of the IRS, then you should not worry, because there's a tax receipt for every smuggled USB. And if you're wondering what goes on to those drives, then it's stuff ranging from Wikipedia articles to South Korean soap operas, which is evidently a threat on North Korea. Anyways, there's another explanation, which is actually to sell this antivirus as a product in the global market. And that's actually stated by North Korea itself, which says that it devoted some of its efforts to develop this product as a worldwide product. So we can actually corroborate this by looking at the 2005 version of SiliVaccine, and we can see that this version was written both in Korean and English, which may hint at the fact that the developers of this version wanted it to appeal to English-speaking users as well as Koreans. So at this point, you must be wondering, how did we get our hand on this software? Well, the answer to this lies in the Bloomberg article I mentioned earlier, which linked to a blog post written by this guy, Martin Williams. Martin Williams is an independent journalist who covers various news items related to North Korea. And he himself got this software back at 2014 through an email, a very weird email from a guy naming himself Kang Yong-hak, which supposedly lives in Japan, who sent him this antivirus as sort of a journalistic lead. And keep this email in mind, because we will refer to it a little bit later. Of course, Martin agreed to share the software with us, and that's a place to thank him, because he really made this research possible. So what were our goals when we started this research? So first of all, we wanted to understand how this program is built. What is its architecture? Through which we really wanted to have some sort of an anthropological view on North Korean engineering practices, meaning how would engineers with restricted resources, like those in North Korea, would tackle a complicated problem like building an antivirus from scratch. Of course, we wanted to find any kind of mechanisms that could have been put deliberately in place, in particular, any kind of backdoor that could have been set up by the government so as to spy on its citizens. And with that in mind, let's start the first part of this talk, which is actually the architecture of this antivirus. And I'll just go through the various components, the essential components of the software, so that you'll have a common understanding of how it's built. And let's begin doing that by looking at the software libraries that comprise this antivirus. The first of which is called svshell.dll, which is basically a shell extension for Windows, which in particular adds this context menu entry you see right here, which allows the user to scan for files manually with this antivirus. So you know what, let's just see this feature in motion. So here we have some malware. We're trying to scan it with the antivirus, and nothing happens. Which is, you know, basically it seems like they had some problem with the QA on this feature, but, you know, what the hell. Moving on to the second library here, it's called svkernel.dll. And that's actually the file scanning engine of this software, which is in charge of it has the logic that implements the virus scan of files. This DLL contains 20 exports, as you see right here, which have the names svfunc001 through svfunc020. If you're looking at a naming convention you should never use, and that's a good example. And of course, the verdict of whether a file is malicious or benign is based both on the logic constituted by this DLL and a bunch of signature files that also reside within the package of this software. Third DLL here is just meant to deploy other components. We'll just skip through it. Next part of the next group of components we have here is pretty self-explanatory. Those are the GUI components of the antivirus. The first of which is one called svtray.exe, which is this small tray menu you see right here. And it allows the user to access any other GUI windows inside this program. So for instance, you can access the following utility called svmain.exe, which is the screen you see right here, which allows the user to scan for malicious files. You can play around with some of the antivirus's configurations. You can whitelist some of the files or blacklist other files. And essentially, this is a GUI one-stop shop for all the software's features. This component actually loads a driver called svhook.sys, which conveys some metadata on processes from the kernel space. We'll discuss this component a little bit later in the presentation, so keep it in mind. Another component we have here is also pretty self-explanatory. That's the update utility. It's basically meant to download some update components, whether it is signatures or binaries, and deploy them on the client's machine. Whenever those components are downloaded, they are checked by an integrity checker called svdiffupd. And basically, this client is talking to a server that resides within the DPRK. Because remember, in the DPRK, or North Korea, we have a closed network, an intranet. There's no access to the internet, and this is why the update servers will reside within North Korea. And the update protocol through which this whole thing is going to works on top of HTTP. And you can see some of the messages that are exchanged between the update client and server right here. But what I'd really like you to notice is the vast amount of information conveyed through those messages. And you can see stuff like a serial number and an interface number and an IP and other kinds of information that are passed on these update messages, which for the most part is pretty suspicious. But you know, since we don't have any access to the real servers, we can't tell why this information is collected. So you know, we just can assume that the North Korean government wants to collect some information for some reasons. But anyways, by looking at this protocol, we've stumbled upon some peculiar implementation details. So for instance, if you look at the content length field of the HTTP header, you can see that there's a typo here. They used an underscore, whereas it should be a dash. And also, the user agent that is supposed to be that's supposed to convey the identity of this client to the update server is also somewhat peculiar. So instead of actually changing the user agent field in the HTTP header, what the developers did was actually to append another field called user dealer, which I have no idea what kind of dealer they had in mind, but it has nothing to do with HTTP. And speaking of dealers, we have another component here called SVDealer, which is actually the real-time protection component of the software. And this is essentially a service that monitors files upon interaction with them and scans them on the fly. So for instance, if you want to click on an executable, then it will be first scanned and only then executed. And in order to achieve this, this component loads another driver called svfilter.sys, which is a file system filter driver, which again intercepts all requests, all the user requests or interactions with the file system, and issues the particular files for scanning to SVDealer before actually committing the action itself. And again, we'll discuss this a little bit later. So at this point, I should mention that the two components that actually issue scanning tasks here are SVDealer and SVMain, which would obviously have to load SVKernel, the file scanning engine, for this purpose. But to conduct a successful scan, they would also need a bunch of signatures, which is why this software has about 31 .spf files, which we refer to as the pattern files, which constitute the malware signature database of this software. So the final component we are going to discuss here is called STS-TDI2.sys, which is essentially TDI network filter driver. And if you have no idea what I just said, that's perfectly fine, because essentially what this component does is nothing. And it turns out that while this component is supposed to be some kind of a connection pool that intercepts TCP connections, it never gets queried by any other of the components here. And eventually just sits there doing pretty much nothing. We suspect that this is just a residue from an older version of this antivirus, but really, who knows? So another noteworthy thing here is that most of the components you see here were packed with the Themida protector, which is usually pretty vicious for reverse engineering. Fortunately for us, the developers of SiliVaccine did not set any particularly nasty features of this packer, and we were able to handle it with relatively moderate effort. And what you see right here is like the full architecture. It's a little bit complex, but what I really like you to focus on out of everything here is a component that we've already discussed. That's SVKernel, which again, I remind you, this is the file scanning engine. This is the heart and soul of this antivirus, which is exactly why we are going to discuss it next. And we'll begin the discussion on SVKernel by looking at what every good reverse engineer looks at. Strings. And by looking at the strings of SVKernel, which you can see right here, we decided to do another very advanced thing that every reverse engineer does. Look them up in Google. And much to our surprise, we stumbled upon another file called vsapi32.dll. Now, here's, ladies and gentlemen, where it gets interesting. So, what is vsapi32.dll? Well, it turns out that this is actually a file scanning engine. But it's not just a file scanning engine. It's the file scanning engine of Trend Micro, which was, as you may understand, quite shocking for us. But it begs the question, did the developers of SiliVaccine actually use this component as is, or did they do something a little bit smarter? Well, let's find out. So here on the screen, you can see a binary diff between the Trend Micro engine and the SiliVaccine engine. And you can basically see that there's a 100% match on more than 1,000 functions between those two engines, which is like a quarter of the SiliVaccine's engine code. Also, you can see that some of the export functions here have an identical match. If we look a little bit deeper, then it turns out that actually all of the first 18 functions in SiliVaccine's engine map to some functions in Trend Micro's engine. And just to portray it a little better, let's take a look on 3 sets of such functions and compare the call flow graphs. And as you can see, for the most part, those functions are pretty similar. But I would say that it would be a little bit more interesting to see what are the small nuances or the small differences between those pairs of functions. So as an example, let's take this pair, vsinit and svfunc005. And you can see here this function vsinit, which is basically meant to just initialize some struct prior to conducting a scan. And what I'd like you to notice here is this usage of the memset function, which in the Trend Micro case is just a call to a libc function, whereas in SiliVaccine is the inline version of this function. You can see the same phenomenon here with the memcopy and qmemcopy, which is the inline equivalent of memcopy, which to me at least may suggest that whoever wrote the SiliVaccine engine had some kind of access to a proprietary resource of Trend Micro, which enabled him to turn on some compiler optimization which was not turned on in the Trend Micro case. Let's look at another pair here, which is vsget vscinfo and svfunc004. And in this case, this function is meant to just initialize some struct in memory with some metadata about the engine itself. And here we can again see some function inlining, but what's interesting here is that we can see the actual version that was used in SiliVaccine, the actual Trend Micro version that was incorporated into the SiliVaccine product. So we can see that they used version 8.910, which we know was released around 2008. And remember, this software that we are looking at right now was released in 2013. So they were basically using a 5-year-old engine inside their software. The final example here is this pair of functions, vsquit and svfunc006, which is just a basically cleanup function for various objects in memory. And we can see that in the SiliVaccine version, there is a call to a function I named svio driver cleanup, which is just a function that unloads a legacy SiliVaccine driver. And what you can witness here is basically a call to a proprietary SiliVaccine function from within what used to be a Trend Micro function. So this again shows that whoever wrote this software had, to me at least it seems, had some access to proprietary Trend Micro resources. At this point I should mention that we addressed Trend Micro with this to get the response. They were very cooperative, and they gave us, so before talking about Trend Micro, do you remember the 2005 version? So we checked this version as well, and as it turns out, this version also used Trend Micro component, only they used kernel mode, the kernel mode equivalent of the engine that we just saw, which really suggests that this sort of copyright infringement was not a one-time thing. And of course, we addressed Trend Micro, as I already said, and they gave us their official response. And essentially, what Trend Micro says is that they confirmed that the engine in question was used by SiliVaccine. They state that they never cooperated with North Korea to develop this product, and that they basically have no idea how their engine ended up in SiliVaccine. They do hint, though, that there could have been a possible leak from one of the companies they cooperated with as OEM. And in this sense, I can say that other than being a North Korean product which is developed away from the public, it's pretty hard to detect Trend Micro's engine inside SiliVaccine. And there are quite a few mechanisms for this, and I'll let Michael tell you a little bit more about them.
Thank you, Marco. So we just realized that SiliVaccine is essentially using Trend Micro's engine, and we're wondering if it's using the same engine, does it mean it's using the same signatures? So if we compare them on the surface, they look quite different. SiliVaccine uses multiple small files, while Trend Micro uses a single large file. And if you do a basic comparison, you can find no similarity in structure or strings. So we looked deeper, and we found the place in the code inside SiliVaccine where the pattern files are actually being loaded. And it happens in SV kernel in one of the export functions, the proprietary export function. And here we can see that a pattern file name is being constructed, a handle is being created to that file, the contents of the file are being read, and then the contents are sent to some sort of a decryption function. Afterwards, the decrypted buffer is appended to a memory, to the global area in the memory, and then the ID of the pattern file is being incremented and the process repeats. So essentially what this function does, it loads all of the pattern files one by one, decrypts them, and appends them all together. Now, before we talk about the encryption itself, let's talk a moment about the encryption key, because there's something interesting here. So this is the encryption key, you can see here. It's a seemingly random English string. So we wondered, does this mean anything in Korean maybe? And turns out, no, doesn't mean anything in Korean. But an interesting thing happens if we take this string to English Korean keyboard and try to type it while we accidentally forgot to switch to English. So we would get this Korean string. And if we translate this Korean string to English, turns out it literally means pattern encryption. So yeah. Now, regarding the encryption itself, here we can see SHA-1 and a lot of encryptioning going on. Basically, we didn't really bother understanding everything because we were simply interested in the decrypted pattern files. So we dumped them from memory. And now when we compare them, suddenly they look quite similar. You can see an almost identical header. And if we scroll a bit down, we can find the exact same strings. In fact, a simple comparison of the strings show a match more than 90%. And the difference is probably due to version differences. And here we can find the Trend Micro's entertaining names, Trivial O, Surrender E, and DJ Virus, which we think is kind of fun. So now we decided to test this thing. So we took a bunch of files and scanned them with SiliVaccine, and they were all detected. And we scanned them with Trend Micro, they were also all detected. But there's something interesting. Although they're using the same signatures and the same strings, we're not seeing the same strings as an output, which is suspicious. So turns out SiliVaccine actually renames the signatures before displaying them to the user. And here is an example to show you how it works. So we take a Trend Micro signature, Troj Steel 1. And what SiliVaccine does, it copies that signature. It breaks it down by removing any underscores and dashes. It then replaces the prefix with a custom dictionary. So a Troj is replaced with TRJ. The suffix is replaced, so a number 1 is replaced with the letter B. The casing is modified, and it's all being put together with dots. And now you get a SiliVaccine signature. So here is the dictionary SiliVaccine uses to translate prefixes. And here's the dictionary for the suffixes. Nothing very interesting. But what is interesting with all of that is that it turns out, if you think about it, the authors are probably trying to hide something. So the files are protected with Temida, so you can't see any strings in the binary files. The pattern files are encrypted. You can't see any strings there either. and the malware signatures are renamed before being displayed to the user. So essentially you have no easy way of knowing that this product is using Trend Micro. Moving on, let's talk about some of the fishy things going on inside this product. So during our analysis, we couldn't help but notice that many of the binary files contain a certain string, which is pretty unique looking, and this is mal.nucrypt.f. That's the string. So we realized this is probably a renamed SiliVaccine signature because of the format. But what was renamed here? So let's run our renaming algorithm in reverse, and we will get mal.nucrypt5. Sorry, mal_nucrypt5. But what is going on with this? What is going on with this signature? Well, here are two instances where this signature is referenced. We can see both of the instances are in file scanning functions. And here we can see a file is being scanned. And then there is an explicit check to see if the file was detected to be malicious and if the detection name is mal.nucrypt.f. And if that's the case, then this is simply ignored. And this is suspicious. So we wanted to test this thing. So we took 6 files that are being detected by Trend Micro as mal.nucrypt5, and we scanned them with SiliVaccine, and they were all not detected. So actually this is quite surprising, because when we did some QA on the whitelisting, you can see that it's mostly okay, but in one instance they actually made a typo and whitelisted a completely different thing. So the whitelisting still works though, because this instance specifically is redundant. Which begs the question now, what the hell is nucrypt? So what is whitelisted here? Well, according to Trend Micro's encyclopedia, which is the thing, we can see that they describe malnucrypt5 as some kind of signature related to old malware, which has no relation to North Korea. But a deeper inspection, actually, if we look at the signature format itself, we can see that the mal prefix is used for generic detection names. So it means that this signature is actually a generic detection name that can detect more than it was originally intended to. So we can't really know what was the malware, or if it was a malware that was whitelisted here. But we can speculate on why the whitelisting was being done. So the most obvious speculation is because there is some kind of an existing North Korean tool installed on the citizens' computers, and they don't want to alert the citizens to that tool, or maybe to detect it as malicious. It's also possible that they want the option to create such a tool so that it will be detected by this signature, so essentially not detected at all. It's also possible that since they're using a third-party engine, that engine detects one of SiliVaccine's own components as a malware, and so they wanted to avoid it. And it's also possible that it's false positive management. We don't think so. So moving on, let's talk a bit about the kernel side of SiliVaccine. As you mentioned, SiliVaccine uses 3 drivers, but essentially only 2 are actually utilized, this svfilter and svhook. So let's focus on them. Now, snooping around, we can quickly understand that something going on here. The address of entry point is in the relog section in both of the drivers, and it seems to be packed by something called bobcrypt, which is, again, suspicious. Now, what the hell is bobcrypt? We never heard about bobcrypt, and turns out, if you look it up in the internet, it actually exists, and it's a very old Russian packer that supposedly contains advanced protection features such as anti-debug and polymorphic code. This is not very good news when you're dealing with a kernel driver. So we thought, wait a second, before we dive in, maybe we can find some kind of an answer by just looking again from the outside. And turns out we found our answer, and the answer is 42. Seriously, the answer is 42. Seems like the whole protection feature here is that the text section, which contains the code, is XORed by 42 hex, single byte XOR. So now that we have managed to open the drivers, we can look inside and we can see, well, let's start with SVFilter. So SVFilter is the file system driver, as we mentioned. It's loaded and utilized by SVDealer, which is the real-time component, and has two main functionalities. It's responsible for real-time scanning on file access, so it intercepts file access to issue a scan, and it also protects the antivirus binaries. But really, it takes you quite some time to, took us quite some time to realize that this is the only two things this driver does, because the code of this driver is a mess. And I'm going to save you some time and really explain you the flow by simplifying it. So the process, the driver starts by wasting some time doing redundant checks that don't amount to anything. It then goes on to check, after a while, to check if the file that is being accessed, if the file that is being accessed is one of the AV components. And if that's the case and the process that is accessing the file is not the AV itself, then the access is denied. Otherwise, it goes on to waste a lot more time. Again, doing some things that we don't really understand why it's being done. It doesn't look like obfuscation. It just looks like garbage code. And finally, it moves on to scan the file with SVDealer. So it intercepts the file access and issues a scan command to SVDealer. And if the file is found to be malicious, then the access is denied. Otherwise, the access is allowed. Now, the second driver is SVHook. It's loaded and utilized by SVMain, which is the main GUI component. And contrary to its name, it doesn't actually hook anything. Instead, it's used to query object metadata from the kernel. Really, it is pretty odd and confusing. Again, it has a lot of code, 13 ioctals, but only a little of that code is actually used, and it's very buggy. So, for instance, I said that SVHook works with SVMain, but it really seems like these two components were developed by two different developers. So here we can see the developer of SVMain programming SVMain to use one of SVHook's IO control functions. And the buffer size, the input buffer size of the IO control operation is 12 bytes. Now you would assume that the developers have agreed that that should be the input buffer size, right? But unfortunately, the second developer didn't get the memo and actually returns an error explicitly when the buffer size is 12. So this thing is broken, it doesn't work. Now, looking a bit deeper, I think we can explain why SVHook is so buggy and out of place. Because when you look inside, you see a lot of this. Now, what is this? These are strings, debug prints, referring to the function that is being debugged as sub_800 something. So essentially an IDA auto-generated name. Now, it seems like we were reverse engineering a reverse engineered driver here. So essentially what happened, somebody, the developer of SVHook, took some driver, decompiled it, copied the code, and added debug prints in order to try to understand what he was copying. And it seems he didn't really succeed in understanding, and he also forgot to remove the debug prints. Now we talked quite a bit about SiliVaccine, but to get the full story, I think it's a good idea to talk about the development story behind it. We don't have time.
We don't have time.
How much time do we have?
2 minutes. Okay.
I'll let Mark tell you more about it.
Okay, so I'll try to make it short. To understand who is behind SiliVaccine, we looked at the version info of the files, and we've come across two companies. One is called PGI, which is this weird Korean name. That's a North Korean establishment, which we really, it's not particularly interesting. It's a known establishment. Another company here is one called STS Tech Service, which is basically a ghost company. There's no kind of information about this company on the internet or any active record of it. But still, we can say a few things about this company. It's based in North Korea, as far as we can tell. We can tell it by this brochure you see right here on the screen, which is basically an invitation to a international technology exhibition that took place in Pyongyang in 2006. We contacted the organizers, and they actually corroborated the fact that this company came from the North Korean side. But still the question remains, is this a government entity, is this a private company, or maybe that's the same thing? Also, according to one of our sources, this company is supposedly a subdivision of the KPA, where KPA is Korea People's Army. But that's only a speculation. We can't prove it or disprove it. Basically, how much time do we have? Sorry? 10 minutes? 5 minutes. Good. Okay. So, and as we mentioned previously, Trend Micro thinks that this could be a result of a code leak. Could this code leak be somehow related to this company, STS Tech Service? Well, we don't know that, but what we did see throughout this whole research is a weird connection between North Korea and Japan. And we already saw some of the things connecting here. So we saw SV Kernel from SiliVaccine and Trend Micro's engine, which are similar. But also we've seen a few applications here by those companies, Silver Star and Magnolia, which were both developed in cooperation with STS Tech Service. And as a matter of fact, those two companies which reside in Japan, they reside in the same address, which is quite peculiar on its own. And another thing we noticed is that all of these three companies developed an application with the KCC, where KCC stands for Korea Computer Center, a very well-known research establishment from North Korea. And you may take this one step further and speculate what could be the reason for this connection. But honestly, all we are looking here is just a crazy web of connections. We can't really say what's the nature of these connections or what do they represent. So we'll just need to take it as it is. But still, there are some traces of malicious intent here. I'll let Michael briefly tell you about this.
Thank you. So, at this point, we thought we were done with the research, and we were very happy. But we thought, wait a second, we didn't find any malware, any backdoor. Doesn't mean there is nothing here. And then we realized we haven't actually looked at the package itself, or actually at the installation file. We simply installed SiliVaccine and started analyzing it. So let's skip this part. So let's look at the package now. And we can see that if we extract it, it contains an installation file, which we used. But actually, this is not a real installation file. It's a self-extracting winner archive with no metadata, which contains what seems to be the actual installation file, according to the metadata, and something masquerading as a patch file, which, okay, but when you look at the metadata, it's supposedly related to Microsoft automatic updates, which I think you would say is pretty suspicious, right? Kaspersky turns out this file is signed, but when you look up the signature of the signer, you quickly come to the report by Kaspersky of the Dark Hotel APT, which used almost exact same certificate to sign the malwares there, the malware binaries there. And this is a pretty red flag. And when we analyze this thing, we understand what it does. What it does, it collects information and sends it to a remote server. And turns out this is actually the stage 1 malware of the Jaku botnet campaign. And further analysis confirms this is indeed the Jaku malware. And what is Jaku? Well, it was an ongoing botnet campaign uncovered in 2016 by Forcepoint. It targeted mainly Korea and Japan. And while it infected a lot of victims, The later stages of the malware were used only against select group of individuals, with North Korea and Pyongyang being the common theme between those individuals. Another interesting thing is the connection outlined by Forcepoint between Jaku and Dark Hotel, which in our case, the certificate that was used in both of the campaigns is another such connection. So who was the target here? Well, it seems to us that this whole thing was simply a spear phishing attempt at Martin Williams, who gave us this sample. It could be that Jaku is an integral part of every SiliVaccine installation. We don't think so. And finally, remember that we talked about a whitelisted malware. So now you must be thinking, wait a second, we just found the malware and we found malware whitelisting. So is this what was whitelisted? So when you scan this malware with SiliVaccine, it's actually not detected. But unfortunately, it turns out it's not detected by any antivirus at all. And the reason it's not detected is not because of whitelisting, simply because there is no detection for it, not in SiliVaccine, not in Trend Micro, and not in other antivirus programs. So, yeah. Now, really final words. Just a minute to talk about the conclusions and the open questions we still have. So I think the main conclusion of this whole thing is that SiliVaccine has been illegally incorporating Trend Micro's components, proprietary components, for years over multiple different versions. They also tried very hard to hide this fact, obviously. We saw that there is a whitelisting for a very specific signature. And we saw that the installation comes bundled with the Jaku malware. There are some things, however, that we are not sure about. And I'll let Mark tell you about them.
Right. So what are those open questions we still have? So first of all, how did the SiliVaccine authors gain any access to Trend Micro's proprietary components? That's something we cannot answer. Also, the whitelisting we saw, we don't know what was whitelisted. Was this malware at all? What was the purpose of it? We can only speculate, and we did show you our speculations. Also, did this malware, the Jaku malware, does it come bundled with all the SiliVaccine packages or just this particular package? It's also something we cannot answer because you would have to be in North Korea to answer it. So we prefer to leave these questions to the research community. And although we cannot provide real concise and clear answers to this, what we can see here throughout this whole research is a particular theme, a theme of theft or illegal and shady practices employed by North Korea so as to develop their own homebrew software. A software that otherwise, maybe in a perfect world, would be a totally legitimate product. And with that in mind, I would like to thank you for your attention and hope you enjoyed our talk. One note here, though, if you want to see our research, log into research.checkpoint.com. You can read the full report right there.
Thank you. We have time for about one question. If anyone has anything they really want to ask, just raise your hand and I'll bring the mic over. Yes. 1 second.
Hi, I was wondering, you said that this particular software was used to monitor like external media files. I was just kind of wondering, as far as the detection files, the signatures that you guys saw, you saw that there were, I think that you said there were 90% similarities. Do you see that there were like additional signatures made for those media files that were smuggled into North Korea?
No, I mean, yeah, go ahead.
Actually, they didn't. It's funny, we are pretty sure they didn't modify, they don't even understand how the signature files are built. It's a very proprietary format, and that's the reason that the whitelisting was done at the code level, and they didn't actually remove the signature. It would be easier simply removing the signature, but they did it at the code level because they don't really know how to add or remove signatures. No, they don't try to delete smuggled files. It's It's just the smuggle file thing was just to give you an idea of why such a product would exist.
Thank you to Mark and Michael.
Thank you.